So this is the first step of the recrystallization lab, which is the choosing the right solvent for the substance. So what I did here is we started with having some tap water heated, and it shouldn't be boiling really hard. It should be just like that. So keep controlling the temperature, don't overheat it. And while it was heating, I went ahead and measured 0.1 gram of each substance. So I have here the three first test tubes are resorcinol, the next three are naphthalene, this substance is benzoic acid, and the last three are acetanilide. So what we're going to do, we're going to see if they dissolve their solubility in water, in 95% ethanol, and in petroleum ether. So to be consistent, I prepare them. So my first is going to be water. So in each of the first sample of each substance, I'm going to just put 1 milliliter of water. And 1 milliliter is about a pipette full. So 1 milliliter of water in the resorcinol, 1 milliliter of water in the naphthalene, 1 milliliter of water in the benzoic acid, and 1 milliliter of water in the acetanilide, which is this one. Okay, so now we have the first sample has water, and we want to see how they dissolve in water. Now in this lab, don't put a stopper to shake. Make sure you use a clean glass rod and try to shake it to see if it dissolves in the water. So you see already that resorcinol is completely soluble in cold water. So we don't need to heat it here. Then I'm going to clean up my rod. And it's always a good idea to have a beaker for waste. Make sure you clean it as best as you can and wipe it dry. And then you're going to look at naphthalene. I already see that naphthalene is not soluble. So I'm going to try to dissolve it. But if you look at the structure of naphthalene, it's a completely non-polar substance. So it's obvious that it will be hard for naphthalene to dissolve in water. So what you do, if it doesn't dissolve, put it in water and wait and see if it dissolves eventually. Then the next one is benzoic acid. So here's my benzoic acid. They all have 0.1 grams of the substance, and they all have 1 milliliter of the solvent. So you stir with the stirring rod, and it's obvious that it's not dissolving here. So what I'm going to do, and I already have them marked, this is a different, that's naphthalene, this is benzoic acid. I'm going to leave them in the hot water and see if they dissolve in hot water. Then the last sample is acetanilide right here. So we're going to try to dissolve it same way. And it's obvious it doesn't look like it's dissolving. And if it doesn't dissolve again, you put it in hot water and wait. And I know it's my number one. So we're going to wait a little bit and stir again each of them in the hot water. So this was my naphthalene, and you see it condenses on the stirring rod. So it kind of dissolved, but it also condensed in my stirring rod. So I have to put it back to hot water So it is kind of soluble, but not very soluble. This is benzoic acid, and it's not dissolving much, but we'll wait. And this is the acetanilide. Now, one thing that can happen in the process here is that as you heat it, you might lose some of your water. So it's a good idea to have a little bit of hot water on the side to keep adding in case it evaporates. So it takes a little patience to wait and see. The idea is to make sure you don't have too much water evaporating so that you're consistent with your observation. So for every sample, you have about the same amount of the sample and about the same amount of the water. So here's the naphthalene, and I don't know if you see it well, but it's oily. It's almost like it melted. It didn't dissolve. It feels like at the bottom here, it's accumulating. And so naphthalene is not that soluble in hot water. Cold water, it's not at all, and hot water, maybe tiny bit, but not really. Benzoic acid, though, feel like we need to add a little bit more hot water. But benzoic acid, if it doesn't dissolve, by the way, it means you probably didn't have enough water, so you really need to reach that saturation level. So you don't just give up and say, okay, it's not soluble. Add a little bit more and see if it dissolves. And make sure, of course, your solution is hot. So the acetanilide looked like it dissolved, but we have some kind of impurity down here, but it dissolved in hot water. And benzoic acid needs a little bit more heating, I guess, because we needed a little bit more water in there. So we'll wait for that, but then in the next step, we're going to do the same thing with ethanol. Now, I want you to think about this. What is the difference between a water molecule and ethanol? And of course, solubility has to do with the rule like dissolves like, meaning polar dissolves polar, nonpolar dissolves nonpolar. So alcohol and water are very compatible, so maybe we should expect similar results. So here we go. I'm going to put 1 milliliter of alcohol in my first substance, 1 milliliter in the second, 1 milliliter in the third, and 1 milliliter in the last. So the first is resorcinol, and we saw how it dissolved in water, and we're seeing here that it is also, it's a little less soluble than in water, but it's still soluble in cold water. So resorcinol dissolves in cold ethanol. So it dissolved in water and it dissolved in ethanol without heating. Now let me go back to benzoic acid. I just want to show you that it's dissolving. So benzoic acid dissolves in hot water. So we'll put it back here. That's our benzoic acid. Now, this is naphthalene in alcohol. We saw that it doesn't dissolve in water. And since alcohol and water are similar, we should expect similar results. So it doesn't look like it's dissolving in cold alcohol. I'm going to stir it a little bit with the stirring rod. Make sure your stirring rod is always clean. And just like we did before, if it doesn't dissolve in cold, we're going to heat it a little bit. So I'm cleaning my stirring rod, and we're going to the next substance, which is the benzoic acid in alcohol. So here's benzoic acid in alcohol. I'm going to keep stirring. And it looks like it's soluble, pretty soluble compared to water. So benzoic acid is soluble in cold alcohol completely. Now the last substance is acetanilide. And here we're going to stir it and see if it dissolves. It's better than water. It looks like it's dissolving. So acetanilide dissolves in alcohol. And then we're going to go back to the naphthalene, and you see it is soluble in hot ethanol. Okay? So let's summarize what we've observed. If we look at resorcinol, it dissolves in cold water, so we don't even need to heat it because it will dissolve in hot water. And it dissolves in ethanol. The next substance was naphthalene. Naphthalene is not very soluble in water, but it's more soluble in ethanol when it's hot. Then we go to benzoic acid. We saw that benzoic acid doesn't dissolve in cold water, but it's soluble in hot water, and it takes a good amount of hot water to dissolve it. Benzoic acid is soluble in ethanol, so we didn't even need to heat it, but it was soluble in ethanol. And then acetanilide, we saw that it's not soluble in cold water, but it is soluble in hot water. And then the last one we did is acetanilide in ethanol, and it is soluble in cold ethanol. So these are the results for the two solvents, water and ethanol. The last solvent we're going to do is petroleum ether. So we're going to dissolve we try to dissolve each of these substances in petroleum ether. So just like we did with ethanol and water, we're going to add 1 milliliter of petroleum ether in each. So petroleum ether is a mixture of alkanes, which means that it is non-polar. So let's look at resorcinol in petroleum ether. Cold petroleum ether, we stir and stir and stir. It's obvious it's not dissolving here. So we're going to put it in the hot water for a little bit. Now, one thing about petroleum ether is very volatile, so we don't want to overheat it here because it will evaporate, and you can see it did evaporate. So even if we put a lot, I'm going to add more of petroleum ether, but the nature of resorcinol, the reason that it dissolved in water is probably because it's polar. It's definitely because it's polar, not probably. So because it's polar, it dissolves, and petroleum ether is not polar, so it's obvious that we don't expect it to dissolve. See, it's already boiling over, and it's not dissolved in petroleum ether. Now we're going to go to the next substance, which is naphthalene, and see if it dissolved in cold petroleum ether. So this is naphthalene in petroleum ether. So it's not very soluble, or maybe it is. Let's keep stirring and see what happens. So it's a lot more soluble than in the previous solvents. Now, one problem with petroleum ether, it has the tendency to evaporate quickly, so I'm going to add a little bit more before it evaporates and see what happens. So we can say that it's slightly soluble. It's not completely insoluble. It looks like it is dissolving there, but not completely. So let's heat it up a little bit. And you don't want to overheat it here because, again, petroleum ether, you see, it has very low boiling point. And it looks like it's really dissolving there. So naphthalene is soluble in nonpolar, which makes sense because it didn't dissolve in the water. Then we're going to look at benzoic acid. Benzoic acid right here with petroleum ether. And it really doesn't look like it's dissolving at all. You can see it's kind of a whitish thing. Every time I need to heat it, I'm going to add a little bit more because it evaporates very quickly. So we're going to heat it for a few seconds. And you see it shoots out very quickly. That's the reason you have to be careful when you work with petroleum ether. It's very low boiling point. And again, it's not dissolving. So benzoic acid is not soluble in petroleum ether, both cold and hot. Now the last one is acetanilide in petroleum ether. And of course, you see it's definitely not soluble. I'm going to add a tiny bit more. It's obviously not soluble. Let's heat it a little bit. And it's still not soluble. So, what is the conclusion? In all of these, the only one that was soluble in hot is naphthalene. So that concludes the first part of the recrystallization lab.